Okay, so we're gonna go to the third question. The third question number is 867. Transpose matrix. So let us try to understand what is the question, what is the requirement, and what we need to do. Okay, so the question number is 867 transpose matrix. So it is also given a 2D array. Now 2D array is something which has row and a column. Okay, so it's a 2D matrix. We need to return the transpose of the matrix. If you remember in school or in class, we write matrix where transfer matrix is something, the rows will become columns. So 241 row will become 241 column, minus 10 5 11 row will become minus 10 5 11 column, 18 minus 7 6 will be, row will become 18 minus 7 6 column. Okay, so see 1 2 3 is given, 4 5 6 7 8 9. So 1 2 3 will become 1. Okay, if you see 1 2 3 here written, 4 5 6, then 1 2 3 will become 1 2 3. So 1, the second row 2, first one, and the third row will become 3. Okay, so this is what we need to do. That is the question about. So how we are going to do is we are going to take the first how many rows are there. So we need to count the number of rows. With for this, if you look into this, the matrix has 3 rows. The matrix has array has 3. So we need to find number of elements in an array, which is 3. So R, int R stands for row. Okay, so we have taken here int R stands for row. Int R is equal to matrix dot length. So matrix is the name of the array. So matrix dot length gives us 3. So we know there are 3 rows. Now we need to find the columns. To find the columns, what we have to do is these internal things are counted. Suppose there are 3, right? So we can do like in the last question we have done. We have chose the first array, and then we have chose the first element in the array, and then we have counted how many elements are there in the array. So first we have to choose matrix. So matrix of 0. So in matrix 0th position of element, which is the 0th index. So on 0 index we have taken. So how many elements are there in the 0 index will become number of columns. So here int c, which is int column, is equal to matrix of 0 dot length. So this will give us the value of 3 because there are 3. 1 2 3. If suppose there are value of 4, it will give 4. Suppose see this second one. So here row will be, there are 2 rows, we'll be having 2 rows. So matrix dot length will give us 2 rows, but matrix dot 0 of length will give us 3 because there are 3 elements in 0th index. So that's how we'll be getting the column for this. We got the row and we got the column. Now what we have to do, we got number of rows we have to make and number of columns. Why we got number of rows and number of columns? Because we have to make a new matrix where we have to put the elements. If suppose there is 2 is to 3, then we have to create a new matrix of 3 is to 2. Okay, and there is 3 is to 3, we have to create a new matrix of 3 is to 3 because we have to transpose the element, right? So coming to the solution part, so if it is a square matrix, okay, if it is a square matrix, it will form square, but if it is a different, we have to create oddly. Now what does this mean is, suppose if there is 3 into 3 matrix, then if we rotate it anyway, it will be 3 into 3 only. But if it is 3 into 2 matrix, but then if you rotate it, it will become 3 into 2, just like this. See, it is a 2 index array. Okay, but when we created the transpose of this value matrix, we have got 3, because that's why we need to know number of rows are there and number of columns are there to create a transpose matrix. Once we got the values of number of rows and number of columns, what we have to do is we have to create a new matrix. To create a new matrix, we create initialize int because we are going to put integer values. We name the matrix as output. Okay, and we added 2 empty array because we are making a 2D array. So this is the int output square brackets is equal to new int. And why we have put c into r is because if you see here, there it is 3. Okay, it is like 2 into 3. Okay, there are 2 rows and 3 columns, but when we transpose it, it will become 3 into 2. That's why we have put here C first column integer. It will take number of columns it has in the previous matrix, and the second takes number of rows it has in the previous matrix. And we have created a new array, 2D array for this. Now once we have an array created, all we have to do is we have to put the values of these row values into columns, and second row value again in second column, and third row value, which is this, in third column. Okay, but what we'll do the further what we'll do the initialization. We'll use the for loop because we have a condition. We have to use we have to use every index values. That's why we are using the normal for loop. So what did it for int I is equal to 0? We are going to start with the index 0 and we are going to go till r, which is 3. Okay, 1 2 3, and we are going to increment one by one. So once we are here, what we are going to do is we are going to initialize another for loop. Integer j is equal to 0 and j will be less than, how many times we have to initialize it, till j is less than c, and j value will be incremented one by one. So here at the end, what you need to do is for transposing, if you see the transposing values, the value of at element this 0 row, okay, and 0 column will be 0 0. The value at 4, which is 0 1, will become the value at 1 0. This because see, this is the row. Okay, this is the row 0. Okay, the row 0 has element 2 4 1, and the row 1 has these element minus 10 5 11. So row 0 values to come in, so this value will be here only because this is the same. Even if you put the row like this or if you put the column like this, 2 will be at the same position, 0 0 will be 0 0. But the position of 4 element, which is at 0th row and first index 0 1, will become here, will come here, which is for first row and 0th column, first row and 0 index. So 0 1 will become 1 0, 0 2 will become 2 0. Similarly for all this, so what we have to do is we have to we have to iterate of the row and the column. We have to say the new array we have created, which is the output array, we have to put it in a reverse. So what we have to say, suppose if the row if the suppose the value of index is like original index, so or if suppose the original is at 1, see if you see here 0 and 1, 0 0, and which will be the output of which we expected as 0 and 0. Okay, this here value will be the value of 0 0 is 2, so it is equal to 2. Okay, the same when we do for the second element. If you want to do for the second element, which is original of the second element, is where it's at 0th row and first index. So we access the 0 row, which is the first, and we have to access the first element, which is the fourth element. So where we have to put the element, we have to put it in the first row and the 0 index. So if you see, it will become output of 1 and 0. For this, the value of 4 will change. Similarly, if you want to do for the element 11, so element 11 is at the first row and third column, so it will become like this. Original of first, you have to access the row, which is the row is 1 and the column is 2, and the which will be equal to, where it is the value 11 will come at 2, so this is second, and 1 here 1, so output will become 2 and 1. So basically what is happening here, what is happening is, here the value of original of row, row, and column is equal to output of col and row. So that only we have applied. Output of j of I is equal to matrix of I as j. J is column, I is row. Here I is row, j is column. We follow the same logic and we have transposed the matrix. Once we have done it, and we can run. Once we are run, see that the case will pass. So if you run it, see, that's how you can solve the transpose matrix.